So welcome back everybody to today's lesson, or today's chemistry lesson on counting atoms. So we're going to go ahead and get started here. So how many atoms of each are in the molecule of calcium carbonate? So carbonate is a polyatomic atom, but it can be broken down into carbon and oxygen. So as we're going through this, you can see that there is only one calcium present. So we have one calcium model, and then for your carbonate, that is made up of a carbon with 3 oxygens attached to it. So when you're actually counting each type or each kind of element present, we have 1 calcium, we have 1 carbon, and we have 3 oxygen. So that's all we're going to be doing for counting atoms. So let's go through another example. How many atoms of each kind in sodium phosphate? Again, we have sodium, which in this case, we have 3 of them. Phosphate, again, is a polyatomic ion, meaning that it's a phosphorus attached to 4 oxygens. So here we have 3 sodium, 1 phosphorus, and 4 oxygen. So how many atoms do we have then in iron 3 hydroxide? So this is actually both a iron being a multivalent and hydroxide being a polyatomic, but that doesn't really matter in this case. That's just for naming later. Okay, so if we look here, we can see that you have 1 iron attached to 3 OH groups. Notice that the brackets mean that that little subscript 3 on the outside applies to both the oxygen and the hydrogen. So we have 3 of those groups. So one group is an oxygen attached to a hydrogen, and then we have 2 more of those. So total then we have 1 iron, 3 oxygen, 3 hydrogen. So something that's a little bit more complicated is cadmium phosphate, which can be found, on the top of page 104. So we've given you a little bit more of a complicated example just so that you're able to kind of apply what you know. So you can see that there's a little subscript next to cadmium, which is CD. This tells us we have 3 of those. So C, D, okay, and then our phosphate group again, we have 2 of the total groups. And remember that 1 is surrounded by 4 oxygens. So we have 1 there, and now we have a second one as well. So total we have 3 cadmium, 2, so we have a total of 8 oxygen. Another way to look at this, if you're familiar with distributive property in math, you can think of it as it's the 2 times the 4, and then the 1, because we don't write 1s in chemical formulas, it would be 2 times the 1, meaning that we have oxygen. If that helps you, you can use it. However, you can also just think of it as if you have 2 PO4 groups, that means that you will have, 2 phosphorus and 8 oxygen, because we already had 4, now we have 2 groups of them. So I would like you to pause here and complete the first 6 questions on page 101 to 104. So you'll see that we went through the first box of 3, and now you're going to move on to where you see, start with magnesium oxide, and then you'll be continuing down from there. So pause here, do those, then come back and continue with this lesson. All right, so you should have finished those 6 questions with the models, which was what we were drawing in the previous examples. Now we can go through some rules for determining the number of atoms in each element, each compound. So Subscripts are small numbers on the right of an element, which are those little numbers. They tell us how many atoms of that element are present in a compound. So Br2 means that there are 2 bromine atoms in this molecule. When an element has no subscript next to its symbol, there is only 1 atom of that element. So for example, in magnesium chloride, MgCl2, that means that there is 1 atom of magnesium and 2 atoms of chlorine. When working with polyatomic ions, multiply the subscript outside of the brackets with the subscripts in the brackets of each element. So this is, again, think to math, this is distributive property. So for cadmium 3 phosphate, cadmium phosphate, it means that we have 3 cadmium, and then the little subscript 2 outside of the phosphate multiplies onto the 4, making it an 8, and P, which has an invisible 1, 2 times 1, meaning we have 2 phosphorus atoms. So if it helps, pause for a second, reread through these rules to help you, or you can leave them up as you're working. So now you're going to be completing the rest of the examples, on page 103 to 104. If it helps, you may want to read through page 101, which provides you with a few more complicated examples, and all of the rules are present on that page. So after you have completed the rest of the examples on page 103, 104, if you've chosen to pause the video, please make sure you return back to the video to watch the remainder of the lessons, which will be on writing formulas. So naming and writing formulas for type 1 compounds, we usually call these simple ionic compounds. So naming simple ionic compounds, what we do first, look up the metal on the periodic table and list its name as written. You do not capitalize the first letter when you're writing its name. Next, we want to look up the non-metal on the periodic table. Write its name, starting with a lowercase again, but replace the ending. For example, in chlorine, we would replace the ending with an IDE. So sodium chloride would be the correct name. For your next example here, it would be magnesium sulfur. We change to sulfide. CaF2. If we look at Ca on the periodic table, we know that it is calcium. F is fluorine, so we change this to fluoride. Be careful with the spelling of this one. This was a common mistake on your quiz. Okay, and then our last one is potassium, which is K. So we leave the first word unchanged other than the fact that it's just lowercase. And then oxygen becomes oxide. Okay, so we're always just changing the ending. We'll write it up here. Chlorine, for example, becomes chloride. So it's important that you remember to do that, otherwise it is incorrectly named. So you always must change the ending on the non-metal. So to help you learn about ratios and bonding, I have a chemistry ionic puzzle activity for you to complete. So a couple things to know. So when metals, and that should say non-metals, chemically react, the atoms will tend to form ions, charged atoms. Ions form because the electrons are gained or lost, so gained by the non-metal, lost by the metal, and this is all to do with valence shells. Metals will generally lose their electrons to form cations, positive ions. Non-metals will tend to gain electrons to form anions, which are negative ions. In this activity, you will create models for ionic compounds and observe chemical formula of binary compounds, which just means simple ionic compounds. So, instruction, and I've provided you with an example that will look like the puzzle that you're going to be working with. So cut out the cation and anion puzzle pieces. Place the cards together. So you've seen now chloride, or chlorine is coming in and attaching to one of the spaces to fill the charge on aluminum. Place the cards together and add additional cards of the same ion until heights are equal and you have a rectangle formed. So you can see that it takes 3 chlorine to balance that 1 aluminum with a 3+ charge. This means you have balanced the charges and both of the cation and anions have complete outer shells. So one thing to note, if you do not have a printer for this activity, what I will suggest is that you draw these out by hand. So you don't have to actually put them together. You're just going to automatically draw the puzzle pieces and draw what the final product would look like. It's just a little bit less hands-on. So ideally, if you can print this out, and then you're going to submit photos of the completed compounds to teams. So if we were dealing with counting atoms, here we have 1 aluminum, which has a 3+ charge, and 3 chlorines, which have a 1- charge. So AlCl3 would be the final formula. So for 1 aluminum, we have 3 chlorine, remembering that that little subscript means you have 3 of that atom, and aluminum is 1. We don't write 1s in our formula. So aluminum chloride is the final name. So writing formulas. We're going to write the cation and anions down with their charges. So in this case, we're dealing with magnesium fluoride as our example. So you'll always be given the name. So magnesium has a 2+ charge. Fluoride, which is fluorine, has a 1- charge. With that, you want to write the charge below. So 2+, 1-. And then we're going to count how many positive, counting how many positive and negative charges there are. Step 3, add either the cation or anion until the positive and negative charges are balanced. So you can see here we have added an extra fluorine to balance for the fact that magnesium has a 2+ charge, and we need the fluorines to have a total of 2- charges. So if you add -1 and -1, we get a -2 charge. So this is now balanced. Write the formula based on the number of each type of ion you need. So this is where we have used 2 fluorines to balance that 1 magnesium. So magnesium fluoride, and you'll notice there's a little subscript 2 representing the 2 fluorines present. Okay, so pause here, take a moment on a separate sheet of paper to try these examples. I will walk you through one of them and then you can just skip to the answers for the next ones. Sodium oxide is Na+, and oxygen is O2-. So charge on this one is a 1+, charge on this one is a 2-. So now we need to think, okay, how can we balance this out? O2- already has the 2- charge, but can we make sodium into a 2+ charge? So we already have one of these, but if we add a second one, we now have a 2+ charge to balance out our 2- charge. And now that this is balanced, we're going to write the symbols, Na, and remember the symbols are capitalized, unlike the names. So sodium, we have 2 of them, so we're going to write the subscript 2, and oxygen, we only have 1. So we don't write the 1, you just write the letter. Okay, for this one, you can it will just pop up with the answer for you, so just check over your work. Okay, magnesium phosphide. So I've just made a note here. If it helps you, think of the lowest common multiple of 2 and 3, which would be 2 times 3, which is 6. So 6 would be the charge that we're aiming to get. If you don't want to do this, you can kind of just keep adding the charges until they're balanced. You just need to make sure that you haven't gone so far that the ratio can be divided by something. Okay, so I'll now show you the remainder of the answer. So we have 3 Mg, 3 magnesium, and 2 phosphorus or phosphide. So there is a shortcut for determining formulae. It's just important that you understand the ratios before attempting to use this. So just like before, we look up the elements on the periodic table. So for example, magnesium nitride, we write down, so I'm just going to write Mg, which is 2 plus, and nitride is nitrogen, which is 3 minus. Okay. Write down the symbol and the ion charges, also known as combining capacities. So here we go, Mg2 plus and N3 minus. Now you crisscross, meaning I bring the 2 down to beside the nitrogen, and I bring the charge on the nitrogen down beside the magnesium. So you basically swapped the positions of these, but put them in the lower placement. With this, you need to check to make sure it can't be reduced. So say you had something like 6 and 3. Yeah, 6 and 3 works. So both of them are divisible or can be divided by 3. You would need to divide both of them. Also check for 1s, as we do not write 1s in our final formula. From here, you can write the final formula, Mg3N2. So pause here, reread through this slide just to make sure you've got it, and then you can move on to the practice. So pause here and give these a try. If you're confused, you can follow through with my examples, but it is a good idea to try it yourself first. So try these out using the crisscross method. And you can also check your work using the balanced method. Okay, so for your answers, I'm gonna pause periodically through these just if I need to explain something, but for the most part, the answer will likely just pop up for you. Okay, so with this one, after you've crisscrossed the charges, bringing them down to the lower subscript position, I've just made a note here with calcium because it ends up meaning that there was only one of those. You never write the 1 in the final formula. So you can see I've written it with the 1. That is completely incorrect. Cross it out, scribble it out. Don't include 1s in your final answer. So Al2S3 is your final formula for that one. So with this one, Mg2O2, because they both contain 2s, you can divide both of these by 2, meaning we reduce the ratio. So just like we would in math, if you have a 2-to-2 ratio, we always want to divide this by 2 to reduce it to a 1-to-1 ratio. So putting it into lowest terms, essentially. So a 2-to-2 ratio is the same as a 1-to-1 ratio. So for your final answer, it should be MgO. Okay, so this is your final part of our lesson for today. So if you can continue on with what the schedule says and complete the work, if you skip through some examples, go back and make sure you're finishing those and make sure you're finishing the puzzle activity as well. Okay, we will see you back in our class meeting then.